Welcome back. Today we're going to talk about solving equations, specifically focusing on quadratics. First of all, let's look at what a quadratic equation is. A quadratic equation is an equation in this form. It's ax squared plus bx plus c is equal to 0. That's going to be very important. A, b, and c are real numbers. And a is not equal to 0. You must have a coefficient in front of the x squared term. That's what's going to make it a quadratic. We've got four algebraic methods and one graphical method for solving these. I'm going to run through a couple of examples of each so that you've got a good idea in your head and are reviewing these processes. First of all, let's talk about factoring. We can solve an equation by factoring. We want to set it equal to 0. And after we do that, we can go ahead and use what's called the asterisk method. The asterisk method, as a review, up top here, you put the product of the coefficients a and c. Down here, you put the coefficient b, and then your coefficient a goes here and a goes here. What goes in these two spots are two numbers that add to b and multiply to a. Okay, so they add to the number b, they multiply to a. And so when I set up my asterisk method for this one, a times c is going to be -4. A is going to be 2 and 2. And then down here for b, I've got -3. And I want two numbers that are going to add to b, so add to -3 and multiply to -4. And so it's going to be -4 and 1. Okay, because -4 is -4 times 1 is -4, and then -4 plus 1 would be 3. And so how do I use these? Well, now I'm going to look at these fractions and I'm going to reduce, because essentially it's like a fraction top and bottom. So I'm going to reduce. So there's a factor of 2 in each. So this is going to be 1 over -2, and this one's going to be 2 and 1. These are what are going to go in my parentheses. So because I've got a quadratic, I know I'm going to have two sets of parentheses. And these give me the coefficients of my terms. And so this is going to be on top 1x minus 2. And over here I'm going to have 2x plus 1. Well, now, because we know that if it's equal to 0, one or both of the parts have to be equal to 0. So either x minus 2 equals 0 or 2x plus 1 equals 0. And so my solutions from there would be x equals 2 or x is equal to -1/2, because this would be subtract 1 and divide by 2. Okay, so those are my two solutions. So x is equal to 2 or -1/2. Okay, there you go. You could always plug back in and see what happens. Here's what I'd like for you to do. Try the next example. You can pause the video, try it, and then when you come back, I'm going to explain it to you. All right, so here we go. Again, I'm going to use the asterisk method here. On top goes AC, so on top is 12. On the bottom is going to go my coefficient B, so -8. Over here is A, here's also A. And then I need two things that add to B but multiply to A. So I'm thinking of the factors of 12. So I'm thinking 6 and 2, those are 8, but 6 and 2 don't add to -8, so it's going to be -6 and -2. They multiply to 12, add to -8. When I reduce this, I've got a factor of 2 up here, so it's going to be 2, -3. Over here, it's going to be 2 and -1. Those become my parentheses. 2x. So 2x minus 3. Over here, it's 2x minus 1. And that makes sense. I've got a lead coefficient of 4 here, so it makes sense that my coefficients on my x terms are going to have to multiply to 4. And so that means 2x minus 3 equals 0, or 2x minus 1 equals 0. And if I add 3 and then divide by 2, I get x is equal to 3/2. Or add 1 and then divide by 2. So I'm going to have 2x is equal to 1, so x is equal to 1/2. Okay, that's how that works out. So factoring, use the asterisk method. It makes it very, very simple. Extracting square roots. essentially what we're doing is we're solving an equation here, and there's one little trick that you need to know. It's going to give you directions like solve by extracting square roots or solve algebraically. Well, if I have a squared term here, 2x minus 1 squared is equal to 9, what I can do is I can square root both sides. Well, check out what happens. I'm left with 2x minus 1 equals the square root of 9. Well, the square root of 9 is equal to, and if you said 3, you are correct, but also negative 3. And so what I need to do when I'm extracting square roots is remember that I'm going to have two answers, okay? Because when I am doing the square rooting, that's going to tell me, hey, it could be the positive or it could be the negative. And so here, just like we did with factoring, we've got two answers. So 2x minus 1 equals 3, and 2x minus 1 equals negative 3. Okay? And because of that, what I can do is I can solve this equation and add 1. So 2x is equal to 4. So x is equal to 2. And on this one, it's 2x is equal to, if I add 1 to both sides, negative 2. So 2x is, x is equal to negative 1. All right, so again, you try the next one, and as you do it, know that I'm going to come back. So pause it, try it, come back, and then I'm going to show you how to do it. All right, so this one says, solve by extracting square roots. I told you it could give you the directions either way. So first, 2 times x minus 5 squared equals 17. First, I've got to get it down to where I can actually take a square root. So x minus 5 squared is equal to 8.5. And now I'll take the square root of both sides. So x minus 5 is equal to plus or minus the square root of 8.5. And so when I add 5, check out what happens here. My answer is x equals 5 plus or minus the square root of 8.5. Okay, my math lab is going to want it either in reduced radical form, or it could ask for an exact answer, but this is going to get you there. Okay? That's the basic process for extracting square roots, completing the square. Let's talk about completing the square for a minute. There's a couple of steps to completing the square. I'm going to do the first example and lay out the steps for you next to it. Okay? The first thing we need when we're completing the square is we need a lead coefficient of 1. Okay? So I'm going to divide both sides by 4. Get lead coefficient equal to 1. So the lead coefficient is the coefficient in front of the x squared term. So what I'm going to have here is I'm just going to zoom in just a little bit here. I'm going to have x squared minus 5x plus 17 over 4 is equal to 0. Okay? Now that's pretty good because now I have a lead coefficient of 0. So what I want to do now is get x's alone. Okay? So I'm going to get the x's alone. So I'm going to subtract 17 over 4 from both sides. So I've got x squared minus 5x, and I am going to do a combination x stick. I'm going to leave a little space here, and that's going to be equal to minus 17 over 4, and I'm going to have a little space right here. Okay, now, what am I doing? This is the actual completing the square part, okay? Completing the square works because you're adding the same thing to both sides. You could do this to any equation. So if I add 5 to one side, I got to add 5 to the other side. What I am doing when I'm completing the square is just picking very specifically what I want to add. I want to add b over 2 squared. Okay? I want to add b over 2 squared to both sides. And so what I'm going to do here is I'm going to say plus negative 5 over 2 squared, because this is my b, plus negative 5 over 2 squared. Well, watch what happens here. Now, what I've got is I have the ability to complete this square, okay? Because I know from when I was doing the factoring that I wanted two things that multiplied together to get AC and added to B. Well, now my square looks like this, x, and this is going to be my b over 2. So in my parentheses, my square is now completed by b over 2. And that's going to be equal to this sum right here. So negative 17 over 4 plus 5 over 2, negative 5 over 2 squared would be 25 over 4. Okay? So let's scratch out this example. We're just going to keep going. X minus 5 over 2 squared is equal to, and negative 17 over 4 plus 25 over 4 is going to give me 8 over 4. So x minus 5 halves squared is equal to 2. And now look, check out, this is extracting square roots. And so I'm going to have x minus 5 halves equals plus or minus square root of 2. And so x is equal to, I add 5 halves to both sides, 5 halves plus or minus the square root of 2. Okay? That's exactly how this works. Okay? And so completing the square, here are the steps. I'm going to circle them. Get the lead coefficient of 1. Okay, so I divided by 4. Get the x's alone, meaning put them all on one side. So I subtracted 17/4. I'm going to add b over 2 squared to both sides. Then I'm going to put x plus b over 2 in parentheses is equal to whatever this sum was, whatever I added to that side, okay? So x plus b over 2 squared equals answer, and then extract square roots. Okay, to get my answer. That's completing the square. I'm literally adding something to both sides to complete it, so I have a neat little square that I can extract square roots from. Okay, let's go over to the quadratic formula. Quadratic formula, in the box goes the song. I'll sing it for you. I'll be on tape. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so there's that song. Obviously, we need to know the coefficients of each of the pieces. Okay, so if we solve using the quadratic formula here, I have to set it equal to 0. So to use this, you got to remember the equation equals 0. Okay, so I'm going to have to set this equal to 0. So I'm going to do 3x squared minus 6x minus 5 equals 0. Okay, so as I keep it in the back of my mind, I know I need to subtract 5 from both sides, right? Okay. And so now I've got A, B, and C. So here's my A, here's my B, here's my C. So negative B, so negative 6 would be 6 plus or minus the square root of 6 squared, negative 6 squared, minus 4 times 3 times negative 5, all over 2 times 3. Now it's just a simplification game. Notice, I've got two answers here. Just like in all these other ones, I've got two answers. So, 6 plus or minus the square root of 36. And then this would be 4 times 3 would be 12. 12 times 5 would be 60, so plus 60 over 6 is equal to 6 plus or minus 36 plus 60 would be square root of 96 over 6. And I can extract the square root out of there. So 16 is going to go in 6 times. So I've got 6 plus or minus the square root of 16 times the square root of 6. I should not have drawn that long. over 6 is equal to 6 over 6 plus or minus 4 root 6 over 6. So I've got 1 plus or minus 2 square root 6 over 3. Okay, there's my answer. I have two answers, 1 plus 2 root 6 over 3, 1 minus 2 root 6 over 3. All right, go ahead and try this one. When you come back, we'll do it together. All right, so what I'm going to do is I'm going to move all this stuff to this side. So I'm going to subtract 3x plus 4 because I want it equal to 0 and I want to keep the lead coefficient of 1. So I'm going to have 0 equals x squared minus 3x minus 4. And so here's my a, it's 1, b is negative 3, c is negative 4. So I've got negative b, so that would be positive 3 plus or minus the square root of b squared, so that would be negative 3 squared minus 4 times 1 times negative 4 all over 2. So 3 plus or minus. And I've got 9 plus 16, so square root of 25 over 2, which is equal to 3 plus or minus 5 over 2, which is equal to either 8 over 2 or negative 2 over 2, so 4 or negative 1. Okay? That's how that works. That's the quadratic formula. Okay, so 4 or negative 1. How do we graph here? Okay, so for graphing, we want to try to look at the intercepts. So where does this graph actually equal 0? And so what we can do is we can work with a calculator. I'm going to use an online calculator here. And if we have an equation we can put into our calculator, what we can do is we can find where those intercepts are equal to 0. Okay, so let's find where those intercepts are equal to 0. I have an equation here that I can put in there. So 2x squared minus 3x minus 2 is equal to 0. Well, that's going to be my y equals. Okay, so I'm going to have y equals 2. I'm going to have y equals 2x squared minus 3x minus 2. Okay? And so my solutions to my graph, I'm asking where does this graph equal 0? Well, literally, where does it equal 0? It literally equals 0 where it crosses the x-axis. And so my answers are 1/2 and 2. My graph would look like this. My intercepts would go on negative 1/2. So check out my thing here. Negative 1/2 and 2. And so my parabola is going to have a vertex of, can you see that? 0.75, negative 3.125, so right here. And this is my graph here. On your calculator, you're going to do a trace and find where those things equal to 0. But my solutions are x is equal to negative 1/2 and x is equal to 2. That's physically where it equals 0 because of the way that the values fall. Okay? This next one, I'd like for you to try to solve it. So plug it into your calculator, and in this one, we're going to have the possibility of having 3 zeros because it's a cubed. And so I'm going to graph it, but you go ahead and try it, graph it, and trace where those zeros are, and I'll show you the solution when we come back. All right, so x cubed minus x plus minus 1, x cubed x cubed minus x minus 1. Okay, so check it out. I have the possibility of having 3 zeros, but when I graph it, notice how many times it goes through the x-axis. Check it out. It only goes through one time. So my solution is 1.325 comma 0. So x is equal to 1.325 or 1.325 comma 0 is the point that is the solution. Okay, guys, that's the basics of solving these equations. Obviously, there's tons of different types of types of equations that you could solve for. These are the ones we're going to be focusing on. And if you have any questions, please feel free to contact me. Thanks, guys.